So today's topic really is adding or subtracting rational expressions. And rational is another name for fractions, okay? So we're going to add or subtract rational expressions, but rational, the whole word rational means fractions, okay? So to do this, let's take a look. Example 1, 2, and 3 are basic fractions like 6th grade math, okay? So let's set it up. 1/5 plus 3/5. They already have a common denominator, right? I don't mind doing visual on these because a lot of kids don't really understand fractions, but I like to do the old pie chart, and if this seems so obvious to you, that's okay. Let me just show a picture of what's going on, because I think a picture is worth 1,000 words. So if I do a picture, right, and if you had 1, 2, 3, 4, 5 pieces, right, and I know it seems really obvious to you, but I really sometimes don't think kids understand fractions that well. But if I have really 1/5 of the pie, okay? I really have 1/5 of the pie, and I'm going to add in 3/5 of the pie. So I'm going to add in 1, 2, 3 more. The answer's got to be fifths, okay? Watch. Okay, this is why I like to show it, because visually, if I add those, I've got 4 out of the 5 pieces. You agree? There's no tenths up there. You agree? Yep. Guys, you have to pay attention. There's no tenths. And a lot of kids like to do this, and I will do it wrong, and I'll erase it. But I've seen this. I've seen kids go 4 tenths because they want to add the 5s. But visually, do you see why that can't be possible? You've got 1/5 of it plus 3 more fifths of it makes 4 pieces, but the pieces are fifths. Does that make sense? Okay. So if I go back to this, it's just 4/5. So they already have a common denominator, right? And just add them. Okay, number 2, they do not have a common denominator. I need to make them the same. So if I have 7/12 minus 1/4, 2 ways to do it. One way is you can multiply this by 4/4 and this by 12/12, but that's going to make a lot of pieces. We want to make the smallest that we can. I know if I multiply this by 3/3, everybody agree with this? 3/3, then we'll get 12. So the whole idea is to get the common denominator 12. So now I'm going to do it step by step. We're going to go way back to 6th grade math. So I'm going to get a 7/12 minus a 3/12, right? All right. 7/12 minus the 3/12 because it's just the 1 times the 3, the 4 times 3, and then I can subtract. And when I subtract, I get 4/12, right? 7 minus 3, it's just 12s. Okay, now at this point, that's an okay answer, but we can reduce, right? We can reduce, and why not reduce anytime we can? We reduce this to 1/3. Okay, we divide both by 4, divide by 4, right? Everybody good on that? Okay, this is old 6th grade math, okay? All right, example 3. I've got 5/12 plus 3/8, all right? So we got to make them the same. So there's a lot of different common denominators, but really probably the easiest one is 24. Can you see the 24? I can make them both become a 24, right? You guys remember this from fractions? So I can make this a 24, and I can make this a 24 by multiplying. So if I multiply by 2/2 and by 3/3, they have a common denominator, okay? You have to get a common denominator. So then I'm going to get a 10/24 plus a 9/24, and when I get the common denominator, I just add them, and I get 19, not 48s, but 19/24. Okay, so before I move on to the x's and y's and z's, thumbs up. Everybody remember how to add, subtract fractions from 6th grade. Everybody good?
Yes.
Everybody good, right? So everybody's with me. Yeah, it's going to get harder. So now what makes this particular chapter so difficult is that we put x's in there. It's the same exact stuff, though. It's just x's. X's are numbers. They're unknown numbers, but they're numbers, so the same rules apply. So if I look at the first one, remember, right off the bat, common denominator. Always think common denominator. I'll say it again. Always add or subtract common denominator. Say it one more time. Common denominator, think add or subtract. Add or subtract, think common denominator. One more time. So if I'm adding or subtract, I think what?
Common denominator.
Right? Common denominator, right? So I take a look at example 4. What do you notice?
Common denominator.
They already have a common denominator. Now, just like this fraction here, 4/12 plus 9/12. When I write the answer down, it's 12s, correct? Correct? I mean, you're not going to write 24 here. Everybody agree with that? Everybody agree? I'm not going to write 20 here. So when I write the common denominator here, I'm just going to write the x plus 3. Okay? I'm not going to write it twice. I'm not going to write 24 here. I'm just going to write the x plus 3. That is the common denominator, okay? Then let's add. 3x plus 2x makes a 5x, and a negative 4 and a 5 makes a 1. It is not reducible, so you're done. Okay? Example 5. So, whenever we add or subtract, we think about a common denominator. Okay, what do you see? What do you see? It has a common denominator. So if I were to write down there, common denominator x squared minus 4x, what goes on top is a negative 2x, tricked you, negative 2x, negative 2x, plus 4. Now how did I get that? Because I knew that this was a subtract. Got to be careful with my negatives, right? Okay, now. Am I done? So if I take a look at this example up here, see the 4/12? The 4/12 was reducible. This is reducible also. What I'm going to do is common factor out a negative 2. So if I take this and factor out a negative 2 out of the top, I'll get an x minus 2. And on the bottom, if I factor out an x, I'll be left with a x minus 4. Darn it, won't reduce. Doggone it. It's kind of going to reduce. Darn it, will not reduce.
Do you want us to reduce it on the test?
Anytime we can, but this one won't reduce, so I'll just go back. Yes, I'll mark it half off, right? Yeah, there will be one in here that you're going to have to reduce, okay? Darn, I was kind of hoping that one was reducible. I'll have to fix that problem later so it'll be reducible. Okay. Next example. So what am I going to do? Common denominator. Anybody see anything? What would help me right now? Yes. If I could factor, it's going to help me with the common denominator. So that'll factor into an x plus 1, right? X plus 1 and an x plus 2, okay? So let me rewrite this. So I've got an x minus 1 over an x plus 1 times an x plus 2 plus an x over an x plus 1. Okay, how am I doing? Okay, now by factoring, it's a little bit easier to figure out what the common denominator is. So we need them both to be the same, right? Common denominator, we need them both to be the same. This has an x plus 2. This fraction does not. I'll say it. This fraction has an x plus 2. This fraction, yes, x plus 2 over x plus 2. Just like we did 3 over 3, just like we did 2 over 2, 3 over 3. We multiply by x plus 2 over x plus 2. Josie.
Why can't you just cross out like the x plus ones and then
X plus 1. Cross out the x plus 1s. Where?
There's an x plus 1 in the first.
Here and here?
Yeah.
That's like the great question. That would be like crossing out the 5s. That'd be like crossing out your denominator,
but in the
okay?
last chapter we like crossed.
If I could cancel up yes. If this were an x plus 1, I would. Yes, totally right. Yes, but it's not. It's an x minus 1 and an x plus 1. They're actually different. Good. Good question, Anna. Huh? I can't. Once I start recording, I can't. So, what am I going to get? I'm going to get an x minus 1 plus an x squared plus 2x over my x plus 1, x plus 2, okay? So I put down the denominator, just wrote it down. That's what they have in common. Just write it down once. Just like if I go back, I'll slide it down real quick. Just like this, I had the 12 and the 12, but I just wrote it as a 12, right? Just like I had a 5 and a 5, I just wrote it as a 5. X plus 3, I wrote it as x plus 3. So the same thing here, I write the denominator. What is the common denominator? It is x plus 1, x plus 2. Right? You just write it down as common denominator. Now I also multiplied. Just like I multiplied up here and I made that a 10. Just like I multiplied here and made it a 9, right? So I multiplied there and it got an x squared plus 2x. Now let's see what we got. So I should have then x squared plus a 3x minus a 1 over an x plus 1 over an x plus 2. Dang, I need to rewrite this so we get some that will reduce, because that won't reduce either. We're done with that problem. I've got to find one that we can reduce. I'll find one. How am I doing? Okay? This is some of the hardest stuff we do is this. Okay, example 7. Good. All right, go ahead, Anna. Or, I'm sorry, Sarah. Okay, so one more time.
Wait, you don't have to factor the top part.
I would, but it doesn't factor. I would if it could. You sure?
Yeah.
Okay, let's move on. Example 7. What do you see? We need a common denominator, but do you see anything?
Impossible to square. Like square. Oh.
Will that factor? Yes.
If the, on example 7, if the fraction on the left, if the number on the bottom is x plus 2, x plus 1, and the one on the right is x plus 1, you multiply them both together to get x plus 2 times x plus 1 times x plus 2.
Ah. Can I give you an example? Can I give you an example? So, real quick, let's go back to, okay, Sarah, let's go back to this. Okay, I could make a common denominator of 96 and 96. Okay, look, I could make the common denominator 96 and 96. I could. It wouldn't be wrong. It would not be wrong. But it would be super inflated, right? Now, I could indeed multiply this one by an x plus 1 also. But that's doing more work than I need to. I just need them to be the same on the bottom. Question.
Okay, if you did do it the long way,
something would factor and cancel eventually. Right, something would have canceled. Yes. Just like up here, if I'd used 96 and 96, I would have got an answer that would have reduced, okay?
Wait, so you only cancel things like when you're multiplying? But if I cancel them out, I can
Yes. Yes. Okay. Let me keep going. Hopefully, that's it. Let me keep going on 7, all right? So number 7, I'm going to factor this. So I've got an x plus x over x plus 3. I can't. Once I start recording, I can't. I should have started that way. And Sarah, this is going to answer your question. Again, same thing. Okay. Now, all I need is for the bottom to be the same in the simplest way I can. Okay. So I just want the two denominators to be the same. So the easiest way to do it is just to multiply this one by an x minus 3 over an x minus 3. Sarah, does that make sense? So then they will be the same. X minus 3, okay? You could do more. But let's make it as easy as we can. So if I multiply this by an x minus 3, then the denominator would be the same, wouldn't it? The denominator would be the same.
But you already have an x minus 3.
Right. Right, I do on this fraction. So I have to make them the same, right?
I have to make them both x plus 3 and x plus 3.
Yes. Got to make them both the same. So what is the common denominator? It's x plus 3, x minus 3. Now, They both have the same denominator, don't they? This is a hard chapter. Remember, I warned you guys this is probably the hardest unit we do all year.
Of course, the hardest unit. When I finally started understanding things.
So then I get an x squared minus 3x minus 18, right? Oh, I found one. Good. I knew I had one in there. Okay? Now, I can do more. I can do more. Does anybody see anything? What do you see? So if I factor the top, we'd have an x minus 6, x plus 3, over x plus 3. So what Josie said about 3 minutes ago is you can cancel over multiplication, can't you? You can cancel over multiplication. Can I say that again? You can only cancel over multiplication, which is what we have. We cancel, cancel. We reduced it like any fraction, and we're left with an x minus 6 over an x minus 3, okay? This is going to hurt your head. I warned you, didn't I?
I understand it.
Nice.
I actually understand this. I don't know why, because like the easier stuff I didn't understand, and the stuff I'm like, okay.
Has to do with where you're sitting, Aaron.
I was gonna say.
You are a very smart girl. Okay, are you ready for the next one? Now, listen carefully. Shh, here's a hint. Do not factor the top until you're done. Do not factor the top until you're done, because you have to add the tops, right? You have to add or subtract the tops, called the numerator, by the way. So don't factor the top, because when the numerator, you got to add or subtract. But factor the denominator, factor the bottom. So I'm going to go 2x squared minus 16 over x plus 2, x minus 2, minus x plus 4 over x plus 2, okay? Okay. Kayla, put your phone away. Now, Sarah, I'm not picking on you, but you asked a very good question. What would be the easiest way to make a common denominator?
Times negative 2. X minus 2.
Right? Sarah, you with me? What would be the easiest way to make a common denominator? Right, just x minus 2, because you just want to make the two bottoms, the two denominators the same. So, we're going to go x minus 2, right? So let's see what I get. So on the denominator, I'll have a x plus 2, x minus 2, right? And for the numerator, I'm going to have to do this actually like this, 2x squared minus 16 minus an x plus 4, x minus 2, okay? Alright? Now, this one's going to take some work. Not done. Let me foil. I'm going to foil, right? I'm going to foil. This one's a hard one.
I don't think you can factor the top into the bottom.
Let's find out. Maybe not. Maybe not. 2x squared minus 16 minus x squared. It'll be a positive 2x minus 8. It really will be. You guys know how to do the double smiley. That's where I get the 2, right? Right? Okay. How am I doing?
Good.
Let's subtract the top. I'll have a 1x squared. I'll have a negative 2x, I'll have a negative 16 plus an 8 makes a negative 8. Okay. This is a hard one, isn't it? These are hard. Yeah. Now what? Can I do anything?
Back to the top.
Yes, back to the top. I know you guys love this stuff, don't you? I think we got a little quiz on Friday. Cancel?
Well, you didn't finish that one test.
Yeah. Wait, was it minus or plus 12? Oh, wait. Okay. Yeah, I added. Wait, what's that one right there?
Mr. Davies,
2x squared minus 1x squared.
Listen. Oh. You know the other thing.
Hey, this is the hardest stuff we do. You just have to trust me and let me help you, okay? Last example. There'll be one. Yeah. Okay. Last one. Okay. Yes, Josie. Yeah. Yeah. Of course you can.
How did you get 2x? The minus 2x.
That's a positive 2x. Minus. Oh, that minus 2x. Gotcha. Okay, you ready? This negative right here has to go into all of those.
Oh.
Yeah.
Oh, wait.
Sarah?
Okay.
Which makes a negative 8.
2x.
Negative 16, positive 8. Yes. Go ahead.
It's 2x squared minus x squared. Listen, then y is x. Oh, okay.
You're totally right, Sarah. Sarah, on film, you're totally right. Yes, it is an x squared, right? And where's the negative 2x? The negative comes to the 2x. And I got a negative 16 plus 8. You see the plus 8? Which makes a negative 8. Okay. This is hard, isn't it?
Oh, my brain.
I know. It is the hardest unit we do is this 588. Okay, last one. I'm going to do the last one probably on a separate sheet of paper because I'm running out of room. Do you mind?
Wait, what is
What was the last one?
The last one, example
We did this in like
9.
math is cool.
2 over x. You did math is cool, huh?
Yeah.
All right, I like to hear that. Oh, that's so mean. Okay, here's what I'm doing. Yes, no. Here's what I do. First of all, it's a fraction divided by a fraction, right? So first of all, let's invert and multiply. First step is to take care of that right there, okay? All right with that? So I'll have a 2 over x plus an x over 2 times an x over an x plus 1. Okay? That's the first thing I'm going to do. When I have a fraction divided by a fraction, this is called a compound fraction. It's a fraction within a fraction. First thing I'm going to do, okay? Now,
How'd the x get? How'd the x become the numerator instead of the denominator?
when you divide fractions, what do you do when you divide fractions? Flip. Remember how we invert and multiply, or we flip? Yes, you do. You remember this. If I had 2/3 divided by 5/8, well, how do you do that? Come on now. How do you do that? Remember doing that?
No.
Yep.
Say yes, you did that in 6th grade,
Yeah.
please. Please.
Yes, we did it.
Yeah, we did it.
You flip the second one when you divide, you invert and multiply? Tell me you learned that.
We did this.
You learned that. You learned that in 6th grade.
Yeah, sure. Yeah.
Okay, if you never learned it in 6th grade, this is how you divide fractions. You flip the second one and multiply. So the answer is 16/15. That's how you do it.
Okay.
Okay, anyway, just, back in 6th grade, when you weren't paying attention, that's how they did it, okay?
Alright.
Are you good? So I did the same thing. Okay, divide. Okay, now, I got to add these two. How do I add these two? I got to fix this, okay? How do I add these? Common denominator. So multiply this by 2 over 2 and multiply this by x over x. This is a hard one. Aren't you glad I'm doing these for you? So I get a 4 plus x squared over 2x. I'll let you think about how I got a 4 plus x squared over 2x times x over x plus 1, okay?
Wait, isn't that a 4x?
Common denominator.
Oh, wait, no, but you, okay, yeah.
Are you sure? I mean, if I do 1/7 plus 3/7, is it 4/14? Please say no.
Yeah, no.
Please say no. Thank you, Will. Good. It's not, is it, right? So it's got to be 2x, right? It's going to be 2x. I told you this is hard. There's one last thing I can do, because I am multiplying. Josie, you said if you're multiplying, you can cancel, right? So cancel the x's. Okay. This will not factor, so we're done. Let's go. I'm going to rewrite x squared is 4 over 2 times x plus 1. Hi, Samantha.
Hi.
Okay, so homework, and we will definitely do it together, okay? Agree? 2 thumbs up for me doing the homework with you?
Yes. 3 thumbs up.
Where are you at in your comfort zone? You way down here?
I'm
serious, are you?
what is
Okay, I got it. Aaron's okay.
What am I doing?
Okay, show me. Be honest. Carlos?
I am right.
Are you guys here? Anybody down? Okay, that's all right. If I did the homework with you, maybe we could tilt them up. Okay. All right. Let me stop the recording. Let me talk to Samantha.
One on the bottom because there's only one constant.
That's gone. That's gone. What's left over?
Oh, one x left over. Oh, I have to go.
How do you multiply these?
Wait, what was it, Mr. Davis?